Okay, so this video corresponds to Stats 18, our classwork 4.2, and it corresponds specifically to the portion about transitioning between dot plots and scatterplots. So the data file that I'm going to be using to create these dot plots and scatterplots is called, class data finger. And so you can find this is just using the student view on our course page. If you scroll the way down, the data file is there. If you click on it, it will ask you to save. And then you can choose where to save it. And this .sav file, you can open with either SPSS or PSPP. Okay, I just paused the video for a second to let SPSS open up. Takes a minute. And so this is what it opens up to. And I actually opened that file recently, but I'm going to go ahead and show you. I would go to open another file. And then I can select where I've saved the data. So in this case, I went ahead and saved it to the desktop. And it's the class data finger. Click OK, and we see both our data file and, if I switch over, here's our output file. Okay, so remember, everything we do in the data file, it's going to spit stuff out into our output file. So we have our data here. We have, this is actually labeled wrong, should be major. Okay. So we have major, and there are three types: psychology, sociology, and anthropology. We have lengths of all 5 different fingers. Each one is in its own column. It's treated as a variable. We have the sex of the person. So for example, this female contributed these 5 finger lengths. We can see that this female is over 5 foot tall. So this is height category split into 4. This is height in inches. Hair length is missing for this individual. And then if we split based on their height into 2 halves, we can see she's in the shorter half of the class for height, median split. And if we look at her middle finger, we can see her middle finger is also in the shorter half of the class. So a brief rundown on our variables that we have. So the first thing that we're going to do is recreate the dot plots of thumb length by height from figure 1. Okay. So what figure 1 looks like is it has, refer to my notes, so it's a dot plot that is split, so it's showing the dot plot for the taller half of the class on the bottom and the shorter half of the class on the top, and it's showing thumb length along the x-axis. Okay. So to create that graph, I'm going to go up to Graphs, Legacy Dialogues, and then down to where it says Scattered Dot. We have some different options here. We can do a scatter plot. We can do something a little more complicated, like a 3D scatter plot or some sort of matrix if we're doing lots of variables. For right now, we're just going to stick with the simple dot plot. Okay, I click Define, and it wants me to put our information in. So I know that we are interested in thumb length along our x-axis. You can see that by looking at that figure 1. The x-axis is the horizontal axis at the bottom. We see it's labeled thumb length millimeter. So I'm just going to grab that variable and put it over here to where it says x-axis variable. Now, if all I wanted was all of the data put together, then I would run it like this, right? However, that's not going to recreate figure 1 because figure 1 we can see is split by our height median split. So we can see the shorter half of the class and the taller half. And so if you look along the y-axis, it's labeled on the right-hand side on the figure. We see height median split. So I'm going to grab that variable, and this is what I'm going to use to create 2 different rows, each row showing 1 dot plot. And then it comes out on top of each other. Click OK. And the formatting is a little different because of the version of SPSS I'm using. But if we look, then you should see where the dots correspond to the figure on your paper and that it follows the same general shape. Again, just the formatting is different. So again, we have taller half of the class data located right here on the bottom. and we have the shorter class of the half data located on the top part. Both are again showing thumb length along the x-axis, and it's split into 2 rows based on our height median split. So the next part of this is that we want to explore our data and calculate the means and standard deviations for our shorter half of our class and our taller half of our class. You obviously don't have all the data in front of you, and if you did, it's a pretty big data set, so it would take you a while to compute, to figure out who goes into the shorter half, who goes into the taller half, add them all up, find the mean, find all the deviations, square them, divide, take the square root, right? So it's a complicated process if we're doing it by hand to find the mean and standard deviation for each of these classes, each of these groups. Thankfully, we have this beautiful data set, and somebody came up with this great program that will do a lot of that hard work for us. So the first thing that I need to do is, because of the way this table is set up in our document for number 4, we really want to identify the short half of the class's mean and standard deviation and the tall half of the class's mean and standard deviation. So if I were to follow along with the instructions in the paper, right, so it says go to Analyze Descriptive Statistics, hopefully that term is sounding familiar now, and Explore. Okay. And in this case, what is the variable that we're interested in explaining, right? This is our thumb length, right? So this is the thing that we think depends on something else, the thing we're trying to predict. So we can move thumb length to our dependent variable, and then because we want it split in 2, we're going to move that height median split, which is down at the bottom, into our factor list. And a little tip, so you notice that the name of this variable gets cut off. Sometimes if you hover over it, you can see both the full name and kind of the abbreviation, the name of the variable at the top. You can also right click. Okay, maybe I can't right click using this mouse. Anyway, if you do right click, you should be able, there we go, to change it to say display variable names. And now all the names that you see will match the names at the top of your file. Right, so let me just change it back. So if you have labels on your data, those will show up here. Okay. So again, we want to split this into our 2 sets. So we're going to take this median split, move it to the factor list. Okay, and so factor is another name for independent variable. And in this case, we think that height is going to help us predict somebody's thumb length. So height is our independent variable, or our factor, and then thumb length is our dependent variable. It's the thing we think depends on the other thing. So I'm going to go ahead and change it so we're just getting the statistics. If you leave both, or if you switch to plots, it will print out the box plots for your variable as well. Okay. In this case, we really just want to get the basic descriptive statistics so that we can fill out our table. Okay. So now I'm going to click OK. And we can see the very first thing it shows us is that we had 37 people in our shorter half of the class and 43 in the taller. Probably that has to do with, some people being in the median and it being chosen to go one way or the other. So if we look, we can see in this table, we have shorter half of the class, mean, confidence interval, which we haven't talked about yet, or this 5% trim thing. But we do know what median, variance, standard deviation, minimum, maximum, range, interquartile range. We know what all those terms mean. These last 2, skewness and kurtosis, we haven't talked about yet. Skewness really, again, refers to if we have skewed data, but we're going to ignore those for now. What we really want to focus on here is our mean and our standard deviation. So we see this top part of this table is dedicated to the short half of the class. The bottom part of this table is dedicated to the tall half of the class. So we can see that our mean, let me see if I can get this thing working. Not sure if this is gonna work, but I'm gonna try. Okay, so hopefully we see here, we see the short half of the class, we got our mean, and here's our statistic. So our mean, we could round this to 51.73. We see this line here is dividing our two groups. And so for our taller half of the class, let me go ahead and swap it out. So here we go. Again, we're looking for our mean, and we see our mean here. When we round this, so 57.88, right? And so we can also round this to, let's just round it up to 57.9. And we'll round this one down to 51.7. So now we also need for this table our standard deviation. Oops, let's go ahead and, okay, come back to this color. Okay, standard deviation is here, and we can see it is 6 point, I'm going to round it. Instead of 0.99, I'm just going to say 6.1. We can see for our tall half of the class, our standard deviation read straight across is right there. And again, I'm going to round, and that's 7.9. So this shows you, we have all these numbers, lots of information in this table that gets split out, but really it's about figuring out, what you're looking for, and then following along and finding where the actual number is, right? So kind of reducing down to the important pieces. Okay. So let's go ahead and trash all that. Okay, now the next part is about drawing the model of the population. So for this, I'm going to go back up to my dot plot. And I'm going to draw my model for the population on here based on our dot plot. So again, let me get my screen sketch going. So I'm going to go ahead and stick with my same colors. So using red for the short half of the class. So this data, for example, this point right here, this belongs to somebody who we have actual data for, right? We know somebody who's in the shorter half of the class has a thumb length of about like 63. Okay. But this person is actually in our data set, right? So they are part of our sample. We don't necessarily really care about our sample. We don't want to predict the people in our sample. We already know their thumb lengths, right? We have it recorded. We want to use our sample data in order to predict population data, right? So we want to use the sample information so that if somebody new from our population walked in, we could predict fairly accurately, hopefully, how long their thumb would be, right? So we're never really interested in drawing a model of the sample per se. We want to draw a model of the population because we're always trying to estimate about the population. So let me go ahead and show you how I would draw a rough model of our population based on this. So I see we have a little data here, so I'm just going to sort of follow the curve. Okay. And it's maybe just a little bit long on the right side, but you get the idea. Okay. We can also add a little extra information in here, right? So if we look at number 5 in our packet, it says label the shape, center, and spread. Okay. So what I just drew, that shows us the shape. It's roughly unimodal, right? It's maybe a little skewed on the bottom side, on the left side, but it's not too far off. We also need to label the center and the spread. So if I were to judge where the center is here, I would figure it's probably somewhere around like maybe right in here. Maybe actually a little more left, maybe like here, right? So kind of eyeballing it. So then I would draw in my center and I could label this. What we label for a sample mean, right? We're going to use this equals, and then trying to remember what our shorter half sample mean was. I think it was 51.7. Right, so we've labeled the shape, we've labeled the center. Now we need to find some way to sort of label the spread. So let me just grab this highlighter and we'll get more into this, but for now I'm just going to use this idea to represent our spread. So then I could say our standard deviation for our sample was, and again, I can't really remember. Let me hop back over. So this was 6.1. Oh no, did I lose it? Oh, okay. So that wasn't a great idea. Okay, so learning curve. Okay, so let's, 6.1. Nope, not what I want. Screen sketch, there we go. So I'm just gonna put my shape back in, put my center back in, and that was about 51.7. And now our spread, it's a good chance for you to catch up if you're following along. So our standard deviation was 6.1. So now this is my rough model. We can see the shape, we can see the center, and it's labeled, and we can see roughly the spread, and it's also labeled. So I'll go ahead and let you sort of take a moment and figure out how would you do the same idea of drawing a model like this for our taller half of the class. So on this part. Okay, so let me wipe this out. Now we're going to be, so hopefully you've had a moment to sort of talk through number 6. Now we're on number 7. I want to just show you how to create that scatter plot. So the scatter plot, if you remember, we already saw the term scatter somewhere. Right, so we're going to go, it's very similar. We're going to start in graphs. Go to Legacy Dialogues, and the same place we went for the dot plot, we'll also find scatter plots. So this time, instead of doing a simple dot plot, we want to do a simple scatter. So I'm going to click Define, and now it's asking me, okay, what variables are you interested in? Right, so right now we're just going to focus on the x-axis and y-axis. We want it to be really simple. So if you look at your figure 4 in your packet under number 7, identify which variable is on your x-axis, the horizontal axis at the bottom. So hopefully you see that it says thumb length, millimeter. So that's what we're going to put here for x-axis. Now on the y-axis, which is the one on the side, we can see that it says height median split. I'm going to grab that one and tell it to go on the y-axis. So We're going to leave it as is and click OK. Now again, the formatting is a little different because of the different version of SPSS, but we can see generally the data are the same, right? So we have thumb length on the bottom, height median split on the side, the y-axis, and then we have our two groups. So we have the short group split out on the bottom and the tall group split out on the top. So I want you to take a moment and think about what's different about this scatter plot than the dot plots, and potentially what's not so great about this particular plot. Okay, so hopefully we talked about the fact that you don't really get a frequency, an idea of frequency here. We can see how they're spread out, but that's about it, right? It's not a very informative plot. Another thing to note is that usually we want to put the thing that we're predicting, our dependent variable, over on the y-axis on the side. And we want to put the thing that we think is our independent variable, the thing having an influence, we want to put that on the bottom. So because in this case we're trying to predict thumb length, it's on the wrong side. Right? So it's a super easy fix to change that. We go back to our graphs, back to legacy dialog, back into the same option of scatter, simple scatter, and you'll see that it remembered what I put in already. Since these are in the wrong places, I'm going to take that one out, pull this one down and drop it there, and then move this one to the y. So now we're saying thumb length is our y-axis, it's our dependent variable, or our outcome variable, and x-axis shows our predictor or factor or independent variable. All of those terms are interchangeable. So now when I click OK, we can see it's kind of flipped it over onto its side. So we have our short data down here and our tall data up here on the right-hand side. It's the same data, it's just rotated. Now you'll see, so this looks like figure 5 apart from the formatting differences. In figure 6, what we see is this is what it would look like if instead of using just short half and tall half, if we had 4 categories of height, right? So if we split each of these, so if we took the short half and split that in half, and then took the tall half and split that in half, then we would have 4 categories: shortest, short, tall, and tallest. So for this, we would go back into our legacy dialogues and our scatter plot, define, and instead of using our height median split, we would use this one, height category based on 6-inch categories, right, as it shows in the paper. So then if we click OK there, now we can see it's been split into 4 groups. So we have the people who are, it looks like probably within 6 inches under 5 feet, 5 foot to 5'6", 5'7" to 6 foot, and then over 6 feet. So those are our 4 categories, and we can start to see more of a pattern emerging here than we could here, right? We can sort of see a little bit. These ones tend to be a little lower than these ones, but we're starting to almost see like if you could draw a line through here, right? So it's starting to look like if you found the middle point of each of these, we could sort of start to draw a line. And so this shows us this is where we're going to go with this. Okay. Now, for number 9, we're going to follow up with this idea, but the silly thing is, right, it's a little silly. We're making height into a categorical variable, short, tall, or shortest, short, tall, tallest. Height naturally is not a categorical variable. It is a continuous variable. right? We measure height in terms of a range of numbers from low to high. So we have this actual data. If you remember, if we go back to our data set, we have height in inches, right? Way more specific than height categories. So why would we do this in categories, right? What would it look like if we use the actual inches themselves? So again, we're going to make a scatter plot. You should be kind of getting used to this flow now, right? Graphs, legacy dialogues, scatter. We're still doing just a simple scatter. But now, instead of using a height category on our x-axis, we want to swap it out and use actual height in inches, right? And you see how these have funny little, let me see if I can make that bigger. Right. So, and maybe even a little bit bigger. Okay. So you can sort of see, like, next to each of these variables, there's this little symbol. It either looks like a ruler or it looks like 3 different colored circles. The rulers correspond to our variables that we're treating as continuous. Like, you could measure it along a ruler. It's going to be a range of numbers. Things like sex, male, female, or height category, tall, short, or middle finger length, long, short. Each of those is categorical, and so that's why it's nominal, and it has a different symbol because we've assigned it in our data set to be categories, versus the ones with the ruler we've assigned to be continuous variables, what we call in SPSS scale variables. So I'm going to go ahead and turn that off. Okay. So we have a scale variable now on our x-axis, a scale variable on our y-axis. We're going to try to predict or see the relationship between thumb length and height in inches. Click OK, and now we get the full range of values in height. We're not artificially creating groups. So this will look similar to the scatter plot on your page. And we want to sort of try to digest what this shows us. Right, so I'm going to go back in. So down here, we have height in inches. These are lower numbers of inches, higher numbers of inches. So basically what this means is we have really short people down here. We have sort of average people around here. And we have really tall people up here. Right? So as you move this direction, the people are getting taller. So for example, this dot here represents somebody who's fairly short. This dot represents somebody who's pretty tall. And this dot represents somebody who's pretty average. Now on the other side, we have, just clear those out. On our y-axis, which really is saying our DV or our outcome, we have thumb length. We have low numbers down here, high numbers up here. This means that down here we see short thumbs. Up here we get long thumbs. And in the middle, these are just sort of average thumbs. So if we follow along, if we see this dot down here, this person has a really short thumb. Somewhere in the middle, that means, you know, these people in the middle here, their thumbs are pretty average length. And then these couple of people up here, they have super long thumbs. Right? So as we go up this direction, the thumbs are getting longer. Clear some of that out. Okay. So we can look at our question is asking, okay, so let's find somebody, or let's look for the people who are approximately 59 inches tall. So take a moment and try to identify where you would identify people who are 59 inches tall. Are we looking on the y-axis or are we looking at the numbers on the x-axis? Now 59 should be somewhere around right here-ish, right? 55, 56, 57, 58, yeah, probably about right there. So if we go up, then we can start seeing these points that represent the thumb length for people who are 59 inches tall. So we can see, let me delete this little arrow. We can see that the thumb length for people 59 inches tall ranges from about maybe like 52 down to right on 40. So the people in our sample who are 59 inches tall, their thumb lengths are from 40 to about maybe 52 in length. So if we sort of had to pick like a mean, an average of these 3 points, we would probably try to predict somewhere sort of in the middle, maybe a little towards the top because we have 2 people up there, maybe like, I don't know, around here, right? Maybe a little closer to 50. So what would you predict if somebody who walked in the classroom and we asked how tall they are. They say I'm 59 inches tall is 4'11". They say I'm 4'11". Then what would be a good guess for about how long their thumb would be? Probably we wouldn't want to go below 40. We wouldn't want to go above 52. Probably somewhere around like 48, 49. Somewhere in that like 45 to 50 range would probably be a pretty good guess based on our sample data. So now I want you to take a moment and do the same thing for somebody who is 64 inches. Find out where they are on our graph and identify the thumb lengths for the people who are 64 inches tall and sort of try to estimate what would be a good length to predict for somebody whose thumb is 59 inches. Sorry, that doesn't make sense. Whose height is 64 inches. Okay, so in this video, which corresponds to our classwork 4.2, transitioning between Dotplots and Scatterplots, I showed you how to, if we go back up in our output, how to create a dot plot, how to split it based on a categorical variable. We talked about using descriptive statistics and the explore function to get like our mean, our standard deviation, and then we get a whole bunch of other stuff like min, max, range, interquartile range, median. And we also saw if we move a categorical variable like height, median, split into the factors box, it will split out the data for each level of our factor. And again, factor is just another word for independent variable. We saw how to create a scatter plot and saw that this is not a very good scatter plot. One thing that's wrong with it is it has the wrong dependent variable and independent variable listed, so we flipped them around. Then showed how we can swap it out for a independent variable with more levels. But again, scatter plots are not good for data that are categorical. So we realized, why would we use categorical data for heights when we have continuous data? And our last scatter plot shows that continuous data. We covered how to sort of read this scatter plot, right? How to see what variable is on the bottom, our x-axis, which is our independent variable, and which variable is on the left, which represents our dependent variable. We talked about how to sort of identify what those dots represent in terms of those two variables. And hopefully you can sort of start to see and understand this idea of seeing a relationship between two variables visually using our scatterplot. So I hope this video was helpful. Please let me know if there's anything else that I could do to help you guys. Thanks.